In this video, we're going to be talking about how to graph quadratic equations in standard form, which is the form y equals ax squared plus bx plus c. When we're talking about the graph of a quadratic equation and a parabola, the most important point is the vertex. We have to see where our graph changes directions, otherwise we don't get a full shape. For example, I'm going to show you just a piece of a graph. So if this were the graph of our equation, y equals x squared minus 2x minus 3, and this is all we saw for making a table of values, maybe we see 0, -1, and -2, we would get this little chunk of a graph that doesn't really look like a parabola, even though we know that parabolas should be U-shaped. So if we are asked to graph y equals x squared minus 2x minus 3, the first point that we would need to find is our vertex. I have to know where that turnaround point is. And the way that we do that is by finding our axis of symmetry, the middle of our graph. So actually from the quadratic formula, if you remember that, there's a part of it, that first part, it's the opposite of b, and then the bottom is divided by 2a. This is actually how we find our vertical line, which is our axis of symmetry. So in our equation, I know that a is 1 and b is -2. So if I were to substitute these values into the formula for the axis of symmetry, we would get x equals -2 divided by 2 times 1. And if I simplify this, we get 2 over 2, which is x equals 1. This means that if I were to make a graph of our equation so far, I know that the middle of it should be at x equals 1. Well, if this goes through the middle of my parabola, I also know that the vertex should be somewhere on this axis of symmetry. Well, the cool thing we have about an equation is that it shows us the relationship between our input and our output. So as long as I know my input is 1, I can figure out the output that goes with it. So I'm going to substitute 1 into our equation up here to find our vertex. So we would get y is equal to 1 squared minus 2 times 1 minus 3. And I can type this exactly the way that it is into a calculator. As long as I have my parentheses, I should be okay, just in case there were any negatives happening. So in our case, we would end up with 1 minus 2 minus 3, which is -4. So when I put a 1 in, I get a -4 out, which then tells me that my vertex is at the point 1, -4. So far, I have the vertex. I know this is going to be my turning point. I also know, because a is 1, that it should open up. So my graph should look something like this. I just have to figure out where the points are around it. So the way that we do that is by making a table of values with our vertex as the middle. So because 1, -4 is the middle of my graph, because it's the vertex, I put it in the middle of our table. Now we need some points around our vertex, and I like to keep them symmetric because we know that parabolas are symmetrical. So I'm going to pick in line 2 numbers bigger than 1, so I'm going to go 2 and 3. And then I'm going to pick the 2 numbers smaller, so 0 and -1. Using this now, we're going to create a table of values by substituting each of these into our equation up here. So I'm going to start with -1. So we would get -1 squared minus 2 times -1 minus 3. If I were to type this into a calculator, or we can do it by using order of operations, we would get 1 plus 2 minus 3, which is 0. So we know when x is -1, y is equal to 0. I'm going to do the exact same thing now, but now I'm going to substitute 0 in. So I'm just going to erase these and replace them with zeros. So 0 squared is 0, and minus 0 minus 3 is -3. So now I have 2 more points. I'm going to do the same thing, and I'm going to substitute 2 in. So 2 squared is 4, minus 4 minus 3. So 0 minus 3 is -3. So you might notice, and as Ms. Hong stated in the previous video, that we know because quadratics are symmetrical about the vertex, and since this is the middle, my table should also kind of fold on itself and repeat a pattern. So I don't actually have to do any work because I already know that 3 should also give me 0. Now I am going to check it just to show you that it's true, but if you can just get the 2 points on one side, then we can always reflect them over our axis of symmetry to get those same points on the other side. So 0 minus 0 minus 3 is -3. Oh, whoops, I put the wrong thing in there. Those are supposed to be 3's. So 9 minus 6 minus 3 is 0. So this would make sense that these 2 points match, these 2 points match, and there's our vertex. So if we were to plot this, well, now I'm at -1, 0, 0, -3, 2, -3, and 3, 0. Now my graph looks like a parabola. Its vertex is at 1, -4. Its axis of symmetry is at x equals 1. The vertex is a minimum because it's the lowest point on my graph. And I can already tell that it has 2 real solutions if I were to solve this equation actually. By setting it equal to 0, x would be equal to -1, and 3 if I were to solve this using like the quadratic formula or factoring. So I'm going to show you another quick example. So we have this quadratic in standard form. The first thing we do is to find the axis of symmetry. So we get -8 divided by 2 times -2. And remember, that came from doing x equals the opposite of b divided by 2a. So if I were to simplify this, we get -8 over -4, which is a +2. So automatically, we know that on our graph, the axis of symmetry, the middle, is at x equals 2. It's a vertical line. So I need to find the vertex by then substituting that value into our equation up here. We know that it should be on this line. So we're going to do f of 2 is equal to -2 times 2 squared plus 8 times 2 minus 5. Again, this part can be typed into a calculator if you want, or you can do it by hand using order of operations. But you do have to make sure that you are following order of operations correctly in solving that. So we end up with f of 2 is equal to 3. So now we know our vertex is at the point 2, 3. Automatically, I know this graph is going to open down because my a value is negative. So from here, we're going to make a table of values, and I'm not going to show you all of the steps of this. I'm going to just make the first part and then use symmetry to reflect the second part. So when we set up our table, we put the vertex in the middle. I'm going to do the next 2 x's and the 2 before this. And then I'm going to substitute each of these values into this equation up here. Well, when we put a 0 in, we should end up with -5. And when we put a 1 in, we should end up with 1. Now, without doing any work, I should be able to tell where these values are going to be. If I know that 1 is at 1, then 3 should also be at 1 because this should be symmetrical. We can also see that if I were to actually flip this point over my axis of symmetry, I'm 1 space to the left, so I got to flip it over. I'm now 1 space to the right. If 0 was at -5, 4 should also be at -5 because 2 spaces to the left flips over, becomes 2 spaces to the right. Remember, we use that symmetry to make our lives a little bit easier. So this would be the graph of our parabola. Our vertex is a maximum because it's the highest point. Our axis of symmetry is at x equals 2. We have 2 real solutions if we're looking because I have 2 x-intercepts. I don't quite know where they are, but I know that I have 2 of them. And then our vertex is at 2, 3 that we found, again, from using our formula. So that's how we create a graph of a quadratic when it's in standard form. So really quickly, I want to talk about some applications of when we might use this. Here's a quick problem. Anna's practicing a cheer move where you throw a girl into the air, and the equation h equals negative 16x squared plus 28x plus 7 shows her height after x seconds. What is her maximum height? So again, if you remember when we talked about quadratics and we talked about the fact that they have this U shape and they're symmetric, that maximum height is really just the vertex. So anytime someone gives you a quadratic equation and asks you to find the maximum, as long as it's an opening down one like this because A is negative, then you're really just finding the vertex. So the maximum height for the girl that Anna throws in the air, we would do the opposite of B over 2A to figure out the axis of symmetry, so to figure out this part, and then substitute it in to figure out her height. So if I do that really quickly, we get x equals negative 28 over 2 times negative 16, which is 0.875 seconds. So that's what this x value is. So to find the y value, all we're going to do is substitute this in to this equation. So if I were to get out my calculator and type this in exactly how I see it, because I'm not going to do this in my head because I don't know what any of these numbers would be, and I type this in, we end up finding out that her maximum height is 19.25 feet. So that's how high the girl went. And those are really the types of questions that you might be asked about finding the vertex.